Hello my dear children of class 11 science. Today we do continue with the chapter that we started in the last class, superposition of waves. Number 1, interference and beat. Okay, so this is one of the important chapter. Okay, for class 11 and even you can see this important topic you learn in class 12 and even college also. Okay, now the topic that we are going to start today is interference of two waves. Interference of what? Two waves. Now in the last YouTube video we just did the introduction, what is interference of wave, what is interference, okay, and what is the principle of superposition, okay. Then we classify interference into two types. One is called constructive and destructive interference. Now usually you know that when two waves of same frequency travel in a medium simultaneously in the same direction, so there are two waves that produce from two different sources and having same frequency, having what? Same frequency. If they travel in a medium in simultaneously in the same direction, then due to their superposition, superposition, okay, the resulting intensity at any point in the medium is different from the sum of the intensity of two waves. That's why you can see at some point the intensity of resultant wave becomes large, so the intensity becomes maximum, and some other point you can see the intensity of wave become minimum, or sometimes it becomes zero. And this phenomenon in which there is a redistribution of light energy takes place due to the superposition of two waves is called, or more than two waves, is called interference. This is called interference of wave. Now this interference, as we classified in the last class, also as constructive interference, and constructive means that interference where the intensity of light intensity of wave become maximum, and destructive interference means that type of interference, okay, in which the intensity of wave becomes become what? Minimum, or it becomes zero. But children, remember this interference of the wave can be observed either in sound wave or in light wave. Okay, we can observe in both the waves, sound wave as well as light wave. Okay, now in today's class we derive the expression of intensity. Okay, we derive the expression of intensity of the resultant wave that is actually obtained by the superposition of two waves, and with that we even measure the constructive interference and destructive interference. So these are the topic that you will be learning in today's class. Okay, so for that let me just take the consideration that now for this let us consider the two simple harmonic progressive wave. So we consider what type of wave? Two simple harmonic progressive wave, and they are propagating from different source in a medium, and this wave, simple harmonic wave, progressive wave, have same frequency. Okay, and these two waves are traveling in the what direction? Same direction. They are traveling in what direction? Same direction. So under this, the wave which propagate from a given source, okay, have their own amplitude. That means this wave make the medium particles to vibrate, okay, independently. And I consider that A1 and what? A2, okay, I'm writing this way, A1 and A2 are the what? Are the amplitude. What are these? These are the amplitude, okay, of the wave. These are the amplitude of the waves. Means what are the waves? Two waves. One is the amplitude of first wave, we say A1, and amplitude of second wave, we say A2. Okay. Now, when these two waves superpose each other in a medium, at any point in a medium, okay, they will reach not at the same time, okay, and they may reach at a different time also. Not necessarily the two waves will reach at the same time. That means there will be a certain phase difference between the two waves, and that phase difference is marked by letter phi. So I am writing that phi be the what? Phase difference. Because children, in the last class, in the last chapter, we learned about phase difference and what difference? Path difference. Phase difference and path difference relation, and there is a velocity you learn, particle velocity and wave velocity. But we are dealing with phase difference. So this delta phi and this phi only I consider be the phase difference. So I consider this is the what difference? Phase difference, okay, between two waves. Phase difference between what? Two waves, okay, at any what? Instant, at any instant of time in a medium. in a what? Medium. Now each wave, when they propagate in a medium, okay, then both the wave make the particle to vibrate independently, okay, independently, so that there will be a displacement of any particle medium in a particular direction, okay, and we consider, say, that direction is, say, x-axis, okay, positive direction x-axis, so that the displacement of the wave can be given by the relation, and that displacement I am writing now. Then the displacement, I write down the displacement, okay, the displacement due to two waves, okay, at a point in the what? Medium, in the what? Medium, and that displacement I write down, say, as y1. So one of the wave make the particle displace, okay, and that displacement of the wave, one of the first wave, displacement of the particle, or one of the produced by first wave, is given by y1, and that displacement is given by a1 sine omega t minus kx. See, children, you have learned this relation in the last class only. In the last chapter, the displacement equation of simple progressive wave, simple harmonic progressive wave. Okay, originate from the passes from the origin at certain distance in a medium, and that is given by y1 equals to a1 sine omega t minus kx. Now you know kx means the propagation constant. X is the distance of the particle from the origin which displaced by the first wave, and that displacement of the particle is y1 equals to a1. A1 means the amplitude of the first wave, sine omega means angular frequency into time minus kx. Similarly, there is another wave propagating in the same direction and make the particle displace. Okay, make the particle displace, and that displacement also given by, say, y1, y2 equals to a2 sine omega t minus kx plus phi. So I am doing this way, plus phi. Now this phi is nothing but the phase difference. This is actually what difference I call phase difference. That means when one of the particle displaces, one of the wave displaces the particle in a medium, okay, at certain some time, another wave also displaces the particle after some time, so that there will be an angle difference between the displacement of particle produced by two waves, and that is given by phi, and this phi is called phase difference. So for the superposition of wave, we are taking the two wave, and these two wave have a phase difference, and that phase difference is what? Phi. But you know what happened when these two wave meet each other, when they displace the particle at any point in a medium, okay, then there will be a resultant displacement that we can calculate, and this resultant displacement is due to the superposition of these two wave. These two what? Wave. So I write down according to what? According to principle of superposition. According to principle of what? Superposition. So if I follow principle of superposition, then we can calculate the what? Resultant displacement. Then the resultant displacement. Okay, resultant displacement of two waves. Okay, two waves at a point. At a point in a medium. At a point in what? Medium. And that is given by y, and that result displacement is y equals to y1 plus y2. So y1 is the result displacement produced to that particle by the first wave, and y2 is the result displacement of the same particle produced by the second wave, so that when these two waves superpose or meet each other at this point to make the particle displace, okay, then result displacement is given by y1 plus y2, and this is nothing but the principle of superposition. Okay, now let me substitute the value. The y1 is how much? A1 sine omega t minus kx plus what is y2? A2 sine omega t minus what? Kx plus phi. That means this, between these two waves there is a phase difference, and this is basically a constant phase difference, okay, and that is y, phi, sorry. So this is y. Now what I do now, in the right hand, the second term of this right hand side expression, I do expand trigonometry, and I consider, suppose this is say A, this is say what? B. So, and you know there is a formula that we have learned in trigonometry, okay, and the formula is, since Sin A plus B is given by what? Sin A cos B plus cos A what? Sin B. So student, you have learned this formula in trigonometry. Sin A plus B is equals to sin A cos B plus cos A sin B. Now sin, this quantity if I consider as A, this quantity I consider as B. Now let me expand it. So y equals to A1 sin omega t minus kx plus A2, okay, A2. Now I put the curly bracket. Now I expand this by using this formula. Sin A means what? Omega t minus kx, okay, omega t minus kx, sin A, then after cos B means phi, plus cos A means what? Again, omega t minus kx, okay, kx, and sin B means what? Phi. Now let me open the bracket. If I open the bracket, you can see we get the expression like A1 sin omega t minus kx plus, now this A2 I multiply with this whole quantity. Now it will be A2 what? Sin omega t minus kx, and there is cos phi, plus this A2 again multiply with this one. So A2 what? Cos omega t minus kx and sin phi. Okay, now we can take common, and we can take common in the expression, and the common, basically I take common from these two expressions. So what is common in the expression? Sin omega t minus kx. So if I take this quantity common, sin omega t minus kx, now inside the bracket, now this is the first term. So if I take this common, then what will remain? A1 will remain, plus from this second term if I take this common, then what will remain? A2, and even cos phi will remain, plus, and there is already what? A2 what? A2 cos omega t minus kx and sin pi. But I write this in this manner. So cos omega t minus kx, and I write down A2 what? Sin phi. So look at this. So y, we got this expression. So y is the resultant displacement of the two waves which superpose each other at a medium, at a point in the medium. But this is basically a constant. Children, this is basically a constant because A1, A2 are the amplitude two wave. When they propagate, they are usually constant. Phi is also a constant. So that's why this quantity is constant. Similarly, A2 sin phi is also constant. Now I replace this two constant by another constant. Now I write down, let's say A1 plus A2 cos phi. I replace by another constant, and that constant I write down as r cos say theta. So I replace this constant by r cos theta. Similarly, I replace this constant A2 sin phi. See, A2 sin phi by another constant, and I write that constant as r sin theta. Now the reason why I am replacing this constant by another constant is because when each wave propagating from different source in a medium are progressive wave, then the resultant wave which is produced by the superposition two wave must be a progressive wave. The nature must remain what? Same. Okay, and I need to show that we replace this A1 plus A2 cos phi by r cos theta and A2 sin phi by r sin theta. Now let me put this relation in the expression. Now after putting this value of these two constant by r cos theta and r sin theta in the expression, you see the expression you get as y equals to sin omega t minus kx. Now I replace this by r cos theta plus this is cos omega t minus kx, and I replace this by r sin theta. Now I just rearrange this expression and write the resultant displacement. Now the relation can be further written as y equals to r sin omega t minus kx cos theta plus r cos omega t minus kx sin theta. I just took the constant r in front of this so that this trigonometry identity like sin and cos I wrote together. Now the reason why, because from here I can take common. From this expression what is common again? R. So y equals to r. Now I write down inside the bracket, this box bracket, okay, square bracket, sin omega t minus kx cos theta plus cos omega t minus kx and what theta? Sin theta. Okay. Now the reason why I am writing this formula is because this is again expressed by the same formula. Say this is, say, consider A. If I consider this is A, this is your B, this is your A, and this is your what? Say B, then sin A cos B plus cos A sin B. You know, again we come to the same formula, and the formula is what? Sin A plus B. So I write down sin A means omega t minus kx, B means plus theta. B means what? Plus theta. So you can see the resultant displacement produced by the two wave at a point in a medium is also given by y equals to r sin omega t minus kx plus theta. Now this resultant displacement, okay, produced by the two wave at a point in the medium, okay, is also similar to the displacement produced by the each wave at that point in a medium. And this relation also equation of what? This is also the relation of equation of what? Displacement equation. Let me write this one. So this is also the displacement equation. Displacement equation of simple harmonic what? Harmonic what wave? Harmonic plane progressive wave. Plane progressive wave. So this relation shows that if two waves propagate from a different source in a medium are plane progressive harmonic wave, then by the superposition two wave at a point in a medium, the resultant displacement, okay, will also be a what wave? Simple harmonic plane progressive wave. And due to this simple harmonic plane progressive wave, this R outer act as the amplitude. This constant R act outer as the amplitude of resultant displacement, resultant wave. So this R is the amplitude of what? Resultant wave. So if R is the amplitude of resultant wave, then we can calculate this amplitude. And once you know the amplitude, children, we can calculate even the what? We can calculate the intensity. So the most important thing that we need to derive under this expression is the amplitude and the intensity. Okay. Now R is the amplitude of what? Resultant wave. Where A1 and A2 we have already considered are the amplitude of two waves. Okay. So to calculate this R now, I go back to one of the relations that we have done it, that is, you know, A1 plus A2 cos what? Phi, we replace by R cos theta. Okay, let me just give this as say equation number 1. Okay, and then after we took A2 sin phi, we replace by what? R sin theta. So let me give this as equation number what? 2. So now to calculate this value of R, what I do, I squaring both sides of 1 and 2 and I add both sides. So what I do, I write down this way, squaring and adding equation 1 and what? 2 both sides. So if I do squaring and adding equation 1 into both sides, then I do squaring of left hand side of equation 1. So A1 plus A2 cos phi. I do squaring, and after doing squaring, I'll do add with the squaring of left hand side. That is A2 square sin square phi. First you do squaring, then add equation 1 both sides, and I do squaring of right hand side first. That is R square cos square theta plus, and I add with squaring by the right hand side of equation 2. That is R square sin theta. Now let me expand this relation because we need to find the what? Amplitude. Now this is a formula like A plus B whole square. See, this is just like a formula what? A plus B whole square. You know A plus B whole square formula is what? A square plus 2AB. Okay, let me write 2. A means A1. B means what? A2 cos phi. See, A square plus 2AB plus B square. Now B means what? A2 cos phi. So squaring if I do means A2 square cos square phi. So I have expanded this expression in the form of A square plus 2AB plus B square. Then after the what is there? A2 square sin square phi. And on the right hand side you can see there is a common. So R square inside the bracket I write down cos square theta plus sin square theta. And children, you know what is cos square theta plus sin square theta value in trigonometry? 1. Okay, so I write 1 in the next step. But even I'll take common out here. So A1 square plus 2A1 A2 cos phi. Now in these two the last two expression also you can see the common is there. a2 square common is there. I took a2 square common. So what is remain inside the bracket? It will cos square phi plus sin square phi equals to r square into, now as I said, this quantity is 1 and even this quantity is also 1, this is also 1. So now I write down a1 square plus 2a1 a2 cos phi plus a2 square into 1. See, as I said, this is also 1 equals to r square. So I got r square. So I write down therefore r square equals to a1 square plus, now I write a2 square first, no problem, because everything has positive sign, so we can just write anywhere. So r square equals to a square plus a2 square, a1 square plus a2 square plus 2a1 a2 cos phi. Now if you look at this expression of resultant displacement, the square of the resultant displacement of the resultant amplitude of the two wave, okay, is given by a1 square plus a2 square plus 2a1 a2 cos phi. And once you know the amplitude, we can calculate the what? Intensity. And children, intensity actually measure the brightness. Okay, intensity in case of light measure the brightness. Okay, now for that let me write the formula, and the formula is, since I is proportional to what? I means the intensity is proportional to what? Amplitude, square of amplitude. So intensity, children, I means intensity is always proportional to the square of what? Amplitude. Now we have the amplitude of first wave and amplitude second wave. Okay, so I write down now I1 is proportional to what? A1 square, where I1 is the intensity of first wave, is the intensity of which wave? First wave. So intensity of first wave is I1, so I write down I1 is proportional to A1 square, which means I1 equals to Ka1 square. So K is constant. Similarly, children, you can see I2 is proportional to A2 square, and I2 is the intensity of second wave and A2 is the amplitude of second wave. So this relation can also be written as I2 equals to Ka2 square. So these are the intensity of first wave and second wave. But you know, due to this superposition of two waves, what is we are getting? Resultant amplitude. If there is a resultant amplitude, we have resultant intensity, and that can also be written in the similar manner. So I can write now the intensity of resultant wave as I is proportional to square of R, you know, amplitude of resultant wave. So can I replace this proportional sign to equals to sign? So I write down I equals to KR square. Now what I do, from here only I derive KR. You know, R square we have already calculated as A1 square plus A2 square plus 2A1 A2 what? Cos phi. See, I replace this R square by A1 square plus A2 square plus 2A1 A2 cos phi. Now let me just open the bracket, so that I multiply this K with each term. So it will be Ka1 square, and this is Ka2 square, and again K into 2A1 A2 what? Cos phi. Okay, now you see the expression. Now you know what is Ka1 square? That we have already calculated, I1. You know what is Ka2 square? I2 plus K, I write down 2A1 A2 cos phi. That means we can now measure the intensity of resultant wave I in terms of the intensity of two wave. But still in the expression you can see there is A1 and A2. Now this A1 and A2, the amplitude of two wave, I can even write in terms of I1 and I2. And you know, for that what I do, I write down the relation. But before that, I just consider this as equation number 3. But you know, as I done the relation, I1 equals to what? Ka1 square. If I1 equals to Ka1 square, then A1 means I1 by K. A1 square means I1 by K. If A1 square is I1 by K means, then A1 means square root of I1 by what? K. See, A1 means square root I1 by K. Similarly, I follow the same relation. Similarly, you know, I2 means what? Ka2 square. So I write down therefore A2 equals to square root of I2 by K. Now the reason why I am doing this way, because now I write down this A1 and A2 replaced in this expression, so that your final expression will be written in terms of the intensity of two waves. So therefore, write down from equation 3, I equals to I1 plus I2 plus K into 2. Now what is A1? I replace square root of I1 by K. And what is A2? That is also square root of I2 by K cos phi. Okay, now we can further simplify. I1 plus I2 plus 2K. Now this square root of I1 and square root of I2 are in the numerators. I write in whole square root of I1 and I2 divided by the square root of K in the denominator and square root of K in the denominator. So square root of K and square root of K means K only, cos phi. That's why this K and K cancel out. The final expression now is I equals to I1 plus I2 plus 2 square root of I1 I2 what? Cos phi. Now see, we got the final expression that measures the intensity of resultant wave due to the superposition 2 wave at a point in the medium, and that is given by I equals to I1 plus I2 plus 2 square root of I1 I2 cos phi. That means the resultant intensity at any point depend upon the phase difference. Phi means phase difference between the two waves at that point. So this is the expression that we have derived to measure the resultant intensity of two waves which they superpose each other at a point in a medium to observe the interference. And in the next YouTube video we do with the condition of constructive interference and the condition of destructive interference.